Hi, good morning. Today I am taking class on Fourier representation or Fourier representations of signals. In the previous chapters, we learned the convolution sum and convolution integrals. Convolution sum and convolution integrals provides a convenient way of representing the LTA systems in terms of its impulse response. That is, all LTA systems are represented in terms of impulse response in the time domain. Similarly, here Fourier representation means the representations of signals and systems using complex sinusoids is called Fourier representations. It is representations of signals and systems using complex exponentials is called Fourier representation. Okay. Now, what type of signals are representing? When you see the signals here, signals can be continuous, periodic, continuous, non-periodic, discrete, periodic, and discrete, non-periodic signals. Periodic representations of periodic signals called as a Fourier series. Representations of non-periodic signals called as an Fourier transforms. As a Fourier series corresponds to the periodic signals, whereas Fourier transforms corresponds to the non-periodic signals. Here, that representation we can show like this. That is, this is periodic, this is non-periodic, here we'll take continuous and discrete. Representations of continuous time periodic signals will call it as an Fourier series, that is continuous time Fourier series. Representations of continuous time non-periodic signals are called as a continuous time Fourier transform. Ft indicates Fourier transform, Fs indicates Fourier series. Representations of discrete time periodic signals, you know, that is DTFS, that is discrete time Fourier series. Representations of discrete time non-periodic signals called as in discrete time Fourier transforms. Here, these Fourier transformation tool, Fourier representations, basically we are converting signal from time domain to the frequency domain. We are converting from time domain to the frequency domain using this Fourier transformation tool. Now, we'll take first one, continuous time Fourier series. What is continuous time Fourier series? We know that continuous time Fourier series, that will represent CTFS. Continuous time Fourier series means what? Periodic signals represented here, okay, using Fourier representations. That is, Fourier representations of periodic signals is known as a continuous time Fourier series. Take any periodic continuous time signal x of t, a periodic continuous time signal x of t can be expressed as is x of t equals to summation of k tends from minus infinity to plus infinity x of k e to the power of j k omega into t. This is the representation of continuous time signal. Okay. A continuous time periodic signal x of t is expressed as x of t equals to summation of k tends from minus infinity to plus infinity x of k e to the power of j k omega into t. This is equation number 1, where x of k is the Fourier representation that is in the frequency domain, that is x of k is the Fourier series coefficient, also we can call x of k is equal to 1 by t integration of 0 to t x of t e to the power of minus jk omega into t into dt. This is equation number 2, where x of k is equal to 1 by t integral of 0 to t x of t e to the power of minus jk omega t into dt. This is the Fourier series representation, where t is the fundamental period, where omega is the angular frequency, where omega is equal to 2 pi by t radians per second. Okay, where x of k are known as an Fourier series coefficients, where x of k are Fourier series coefficients here. Now, x of t is the periodic representation of periodic signal in terms of Fourier series, where x of k is the Fourier series coefficient. If you know the x of t, I can find out what are the Fourier series coefficients. If you know the Fourier series coefficients, I can find out what is the time domain signal x of t here. That means here this is, we can express it as a pair x of t, if you know that, using Fourier series you can get its coefficient. Fourier series representation you can get its Fourier series coefficients. Okay, this is a basic definition of continuous time Fourier series. Once again, I'll repeat this. A periodic continuous time signal x of t can be expressed as x of t is equal to summation of k tends from minus infinity to plus infinity x of k e to the power of j k omega into t. This is the Fourier series representation using the Fourier of a periodic signal using Fourier series coefficients, where x of k is the Fourier series coefficient. This is given by 1 by t integral of 0 to t x of t e to the power of minus jk omega into t into dt, where omega is the angular frequency that is given by 2 pi by t radians per second. Okay. Next, let us take one basic problem based on this. Evaluate Fourier series representation of evaluate the Fourier series representations for the signal x of t equals to sine of 2 pi t plus cos of 3 pi t. Also plot its magnitude and phase spectrum. Okay. Also plot magnitude and phase spectrum. This is one question. I have taken one basic example here. What is the question here? Evaluate the Fourier series representation for the signal x of t is equal to sine of 2 pi t plus cos of 3 pi t. Also plot its magnitude and phase. Okay. Now let us solve this problem. What is x of t here? X of t is equal to sine of 2 pi t plus cos of 3 pi t. This x of t is the sum of two signals sine 2 pi t and cos 2 pi t. Okay, let us find out the angular frequency of this. I'll take the angular frequency of this is omega 1 and angular frequency of this is omega 2. That is angular frequency omega 1 is equal to that is 2 pi and angular frequency omega 2 is equal to 3 pi. The angular frequency of this summation, that is angular frequency of this summation, that is x of t, is given by is given by that is omega is equal to GCD of, GCD means greatest common divisor, GCD of omega 1 comma omega 2. That is omega is equal to GCD of what is omega 1, that is 2 pi comma this is 3 pi. GCD of 2 and 3 is 1, pi is common here, I can take. GCD of 2 pi and 3 pi is pi. That is angular frequency of this summation is pi. Now let us express this x of t in terms of exponential signals. That is equation 1, that is x of t can be expressed as sin is e to the power of j theta plus e to the power of minus j theta divided by 2j. That is e to the, that is sin 2 pi t can be written as e to the power of j 2 pi t plus e to the power of minus j 2 pi t whole divided by 2j plus e to the power of j 3 pi t, sorry this is sign is minus here, e to the power of j 2 pi t minus e to the power of minus j 2 pi t divided by 2j. Cos is e to the power of j 3 pi t e to the power of minus j 3 pi t whole divided by 2. This can be written as in terms of angular frequency pi 1 by 2z e to the power of j pi 2 into t, because the angular frequency is pi here, minus 1 divided by 2z e to the power of j pi minus 2 into t plus 1 by 2 e to the power of j pi 3 into t plus 1 by 2 e to the power of j pi minus 3 into t e to the power of 3 into t. See here, let us take this is the equation number 1, and we know that Fourier series representation of any periodic signal x of t is given by summation of k tends from minus infinity to plus infinity x of k e to the power of jk omega into t. When you expand this, x of t equals to when k is equal to minus 2, you will get that is x of minus 2 is equal to e to the power of j k, sorry, omega 2 into t, k is minus 1, x of minus 1 e to the power of j omega, sorry, this is minus 2 into t, this is minus 1 into t plus x of 0 plus x of 1 e to the power of j omega 1 into t, k is 2, x of 2 e to the power of j omega 2 into t, it goes like this. Let us take this as an equation number 2. Just as shown the expansion of this equation. When you compare equation 1 and 2, when k is equal to 2, omega is pi here, k is equal to 2, its coefficient is x of k is equal to 1 by 2j. When k is equal to minus 2, its coefficient is minus 1 by 2j. When k is equal to 3, 1 by 2. When k is equal to minus 3, also 1 by 2. That means I can write the coefficients of this by comparing equation 1 and 2. Comparing equations 1 and 2, I get it is x of 2 equals to x of 2 equals to x of 2 value, that is 1 by 2g. X of minus 2 is equal to minus 1 by 2g. X of 3 is equal to 1 by 2. X of minus 3 is equal to, that is also 1 by 2. For other values of k, here it is 0. Okay, this exists only at 2, minus 2, 3, minus 3. To plot its magnitude and phase spectrum, let us find out the magnitude and phase spectrum. That is magnitude of x of 2 is, how do you find magnitude? Suppose if it is a plus b, a plus jb, its magnitude is root of a square plus b square, and its phase part is tan inverse of b by a, imaginary part by real part. Magnitude is root of a square plus real part square plus imaginary part square. Magnitude, and the phase part is tan inverse of imaginary part by real part. When you take x of 2, this is magnitude of this is, you'll get, because you can write this as minus j by minus j into 1 by 2, you'll get imaginary part is minus 1 by 2 and real part is 0. Its magnitude will become the root of 0 plus minus 1 by 2 whole square. It will be, answer is 1 by 2. Similarly, its phase is, it is angle of x of 2. Phase is tan inverse of imaginary part by imaginary part is minus 1 by 2, real part is 0. That's why answer is tan inverse of minus infinity, that is tan inverse of minus infinity means that is minus pi by 2. Similarly, at x of minus 2, that is x of minus 2, it will become, that is minus 1 by 2j, it will be j into 1 by 2. When take j this to the numerator, it will become minus, minus of minus will become plus. That is, its magnitude is equal to, its magnitude is equal to x of minus 2. Its magnitude is root of real part square plus imaginary part square to become 1 by 2. and its phase part is, it will be just pi by 2, because imaginary part is 1 by 2, real part is 0, tangents of infinity you will get, tangents of infinity is pi by 2. Similarly, magnitude at 3 is 1 by 2, angle at 3 is, x of 3 is, imaginary part is 0, real part is 1 by 2, that's why tangents of 0 is 0. X of minus 3, magnitude of x of minus 3 is, that is 1 by 2, angle is 0. Now let us plot this magnitude spectrum. At 0, 0, 1, 0, at 2, at 2 its magnitude is 1 by 2. This is also 1 by 2, this is also 1 by 2, sorry. This is the magnitude of Fourier series coefficient x of k. Okay. Now, its phase part is, this is k, angle of x of k. At 2 its value is 0, sorry, that is pi by 2 and minus pi by 2 have minus 1, minus 2, 0, 1, 2. At 2 you have, that is minus pi by 2, that is, this is minus pi by 2. At minus 2 it is plus pi by 2, this is plus pi by 2. At 3, 0, at minus 3 it is 0. Okay, this is magnitude plot and this is the phase plot. Okay? This completes the problem. Thank you.